As Mory was saying, when we started Toofon, we had been looking at this for a while, and so we started the company with this mission to replace the inefficient use of conventional transportation like helicopters, up to 500 and potentially, if we get there up to 1,000 pounds of payload, in austere environments and disaster relief scenarios is where we had focused our attention. And as we pursued the market, we realized there's a lot more potential for an aircraft that can bridge the gap between your small commercial drones, which can only carry a quarter of their own weight in additional payload, and therefore end up with a 5 pound payload and nothing more than that, and a helicopter or larger aircraft that are only suited for man mobility or very large payloads of thousands and thousands of pounds. And there was nothing there in the middle. We, from a technological perspective, wanted to develop something that would bridge that gap. And so, we started Toofon out of Caltech, and our approach was to attack logistics and go after logistics as a potential market initially. And we looked at two key performance indicators as we were exploring various customer profiles. Number one was the payload and its weight and volume and the characteristics of a payload. And then number two is the distance and the range that it needs to travel. And that comes into battery power and endurance and things like that. And as we pursued the logistics market, we learned that there are three major challenges that need to be addressed. Number one is the technical limitations of drones, which is something that I just mentioned. Number two is the lack of infrastructure. You have roads for ground vehicles. You just don't have, traffic management and the sort for landing and charging and flying in the air for aerial vehicles, particularly hyperlocal aerial logistics. And then number three was the regulatory challenges. So what we did was over the last 2 years, we built a drone that we tested, at Caltech, and independently we've, come up with a number of inventions that can carry more than its own weight in additional payload. And it can handle adverse weather conditions. We've tested it in 35-mile-an-hour gusts. This is a close-up of the vehicle here. And before I get into the product a little bit more, I'll talk about the logistics challenges that we've explored. This is a global issue. Logistics, supply chain is a big problem. It's very, very expensive. You hear a lot about the last mile, and the last mile is typically 5 pounds to someone's home, but there's 100 miles in the last mile that goes from a distribution center to someone's home. And the majority of that last mile is actually B2B. It's business to business, maybe even regional airports or micro fulfillment centers. And when you look at the market from that angle, you start to see the opportunities for, one, heavier lift capabilities, but also through the lens of payload and range. As we were looking at the KPI, you now have a versatile number of use cases all across different markets. And this particular one that we looked at, we know that competitors like Zipline have been delivering blood and medicine in Africa and have proved that market out with very light payloads. They can't carry more than 4 or 5 pounds. And this is just a quick look at if you wanted to deliver more of vaccines, we can actually make that entire delivery and that operation more efficient by simply having heavy lift capabilities. That's for medical and sometimes even a little bit of commercial. But then you also have defense and you have disaster relief, public safety as markets that we've also explored. And they have actually gone through the stakeholders and potential customers of ours have already gone through and identified these challenges.
One thing I wanted to just begin the Q&A session with was going to Mory, and just you've had a very successful entrepreneurial career while also being an amazing researcher at Caltech. You lead CAST and just in your various leadership roles. One question I had was, how did this come about? What was the research insight that led to what is now Toofon, and what made you decide, because you've done this with a few companies now, like what made you decide this was one that had enough that you actually said, yeah, let's build a company around this?
Through this center we have at Caltech, we have made several breakthroughs in terms of efficient the thrusters and lifters that it's not only include the I would say kinematics, but also the combination with software and how to bring this software into optimal control. You saw the demonstration that this drone dropped equivalent of its own weight. According to Newton's law, it should be shot up into the sky at the equal distance that the other load is falling, but didn't. So that's kind of a very unique technology, basically software and hardware that we have developed through the center, and then it was translated to the company, and company really advanced it to almost perfection. And so that was kind of technologies that you don't want to keep it secret forever, correct? You want to get it to the market, and especially when it comes to niche markets like the logistics of payloads that Amir showed in his nice plot, that there's a white area that nobody's there, and below that also lots of applications. There are a couple of companies, but many of them are not really, I would say, US made, correct? So you want to really fill in that gap, because it's very important for the future of both market and country. So we want to have a US, totally US developed technology and company, and that's a big motivation, in any aspects of the look at it, especially being at Caltech, which kind of we're proud of being the what do you call, the bastion of aeronautics and aerodynamics. We wanted to play a role in that. So that's what was my motivation.
Yeah, no, it's awesome. And then Amir, prior to Tufan, you actually had, you've been at this for a while, right? And so I think there's some less, and I think that's, that we love that, that founder drive, and you're like, I'm gonna attack this problem again. Just maybe walk us through your story a little bit, what you've learned before and how you're applying that now. And
yeah, I mean, most of my entrepreneurial journey was in San Diego or Southern California, also Irvine, Orange County, in smart city and IoT devices, and worked with a variety of different groups, like GE and Cox in the cities and counties in San Diego. So understanding, how the market was going to shape with new technology coming to cities to enable new and disruptive things was fascination over the last 15 years. But I've actually, the first time I talked to firefighters and fire chiefs and captains about using drones for supporting firefighters and introducing that as technology was in 2015. And I remember sitting down in San Diego and having coffee with a fire captain from actually San Bernardino. So it's amazing how things kind of come back in circles. At that time, the market wasn't ready. New drones were just being introduced. So you had small drones, and they could do, surveillance and stuff for them. But to introduce something industrial like this, particularly from a business perspective, is very difficult because you have both software and hardware that's deep tech that needs to be done. It's not just that you're developing hardware or just software. So it's been a very challenging journey. At the time, the enabling technology wasn't there to support that kind of development of aircraft. We, as a small startup, didn't have the called the intelligence and capacity that Mory and his team at CAST and GALCIT bring to the table. And so it was something that where we were exploring the market and what the potential operational efficiencies could be if we did have that. It's a what if kind of scenario. So the market wasn't ready, the enabling technology wasn't ready, and we just really didn't have the talent and skill set to make that happen. Until, say, 3 or 4 years later, when we spoke with Mory, all of the other pieces of the puzzle are starting to fall into place, where the enabling technology is there. You have highly skilled and intelligent people who have looked at Caltech, and the market is now really pulling on this tech.
And David, looking at the questions, there are quite a few questions about sort of unit economics and revenue and so on. Maybe Amir, you could talk about the business models that you're entertaining in terms of an outright sale versus a lease versus a drone as a service kind of approach, and that may, I think, cover a couple of questions that that have come in.
Yep.
Yeah, I see the questions as well. Very quickly, I won't get into the details of cash burn, things like that. We have just raised a Series A, but I'm always interested to talk to investors and learn more about their interests. The unit economics. So we've gotten a range of different prices for the aircraft, depending on which market you go after. You go to some of the underdeveloped countries and they're looking for very inexpensive aircraft. You go to some of the markets where there's more competition from Chinese drones and they're looking for cheaper aircraft. You go to other markets that understand the value of this, and we can price the G25 at up to about $200,000. And for the G150, that's actually even more. That's 350 plus, as we've looked at it. Currently the bill of materials on this thing is about 50K a piece. So we're looking, my goal obviously is to get above a 60% margin on the hardware, and then we can enable software revenue streams downstream by enabling new software capabilities, whether that's from mapping or new types of integrations or predictive maintenance capabilities. This is an industrial thing. It's not a consumer, product. And so we have a commitment on over 15 units at this point. We started going to market 2 months ago and engaging customers on a actual, sale conversation, actual commercial conversations. Prior to 2 months ago, it was mainly just getting feedback from the market on operations, so we know we're building the right stuff. And so now within 2 months, getting demand on 15 units and closing 5 orders this month, just within the last 2 weeks, we're starting to scale up fairly quickly. I don't have enough data to talk about unit economics, but to answer your question, Kevin, about business models, the initial business model is just unit sales. Get the hardware out there, get it in the hands of customers. They've been willing to give us data and feedback and allow us to, through the cloud, access all of that information for improving the product's capabilities. And then knowing operations, I would say we would mature into a business model that's not, we could implement leasing and financing as part of the hardware sales. So that's maybe just more mechanics around the hardware business model. But from a more mature business model, I would say it goes into that software defined vehicle. Imagine a Tesla in the skies. We're now
Right.
using software to generate, and ultimately we probably won't get to this point as a company, but there are so many potentials when you open up, go into any one of these markets for autonomy, and some of them are logistics based. This is what I mean by we don't know exactly what direction that would go to until maybe another 2 years, 3 years down the road. We could end up just being a logistics company, develop an entire network of autonomous aerial logistics capabilities with these drones. So we have to explore how the market is accepting these drones and using them, and how it continues to build out. Because another thing that's new to the drone industry is the post-sale services that have been developing, and companies have been popping up that do drone operations, service, repair, maintenance, overhaul, all of that stuff. Now you're starting to see a lot more post-sale services develop in this industry as it goes through the the initial chasm curve from going into the early adopters phase. And we're noticing that with the heavy lift drones as well now, as there's more demand for it.
Amir or Mory, could you talk a little bit about safety and control systems? And I think one of the videos you showed implied that there's active communication between and among a fleet of drones flying in formation. And how does it work if it's your drone? And how does it work in terms of safety and collision avoidance with other drones that you may not have manufactured, but that may be in the same physical space?
Yeah, Mory, did you want to take that? You're muted.
Yeah, so We are working also very closely. Aside from that, we for internal loop that we have all the standard safety points, but also we are working with another Caltech company that their specialty is just safety, and their software goes over ours without any interference with the internal nonlinear control that we have. So we are very aware of it. Basically, for different operations, as Amir said, we're going to have different virtual safety nets, and that is going to be implemented. Regarding the fleet or swarm technologies, we have not done much about that one, except with communication between the small drone that you saw we developed, and we could basically communicate with it. But now we have requirements or requests from others, the agencies, that they want to see if we can carry 8 of them. And to be able to, at this point, we can carry 8 and safely release them and let them communicate with ground, but we do not have the technology that to bring them back. So basically, these are sacrificable, the drones that they go down and whatever they do, and then they end their mission. Amir, you want to add to it?
Yeah, I mean, I think everything you said, Mory, is on point. The connectivity of the drone is very important to enable that kind of operation, particularly swarming aircraft. And one way that we've looked at it was outfitting existing infrastructure like rooftops, but you could also make this modular and do it in various types of hills and ridges for instance, firefighting, going back to that example, with different nodes that creates that hyper-local airspace, that connectivity. Within that airspace, then you can give specific rules to the drone. Don't carry above this weight, don't go past this, virtual wall, only hover in this area. You can automate and make that entirely autonomous, and then communicate. So one of the biggest issues, particularly in the disaster relief, is interoperability. And having drones integrated into existing air, that's air tankers and helicopters, ground, that's trucks and firefighter operations, and then being able to sync in with the communications rapidly enough so that they can deploy the tools and resources that they need exactly when they need them for the various operations. And then it becomes a force multiplier, because now you can more efficiently manage your assets and resources while you're out in the field. We would bake that into an autonomous network when we're thinking about, let's say, roof-to-roof delivery in a city environment. Because each one of those rooftops, for instance, that we would deliver on, or balconies, are predetermined locations that we establish. And it's not on fire, so it's not dynamic. We can go to that every single day on a regular basis, and that route gets better and better, and the performance of the aircraft becomes better in that route as well. So one of the call it the second degree inventiveness of this aircraft is that it's so smart, we can make it so smart that it can actually adjust in various ambient environments dynamically. So you have the baseline optimal operation of the aircraft, but then say, part of Pasadena is, part of the year in Pasadena is a little bit cold or windy or something, and it will know how to adjust itself in those kinds of environments for that week, for that day, because it's collecting that information in real time. And it's doing the same thing with anything, connected.
Yeah, let me add 2 points. Our takeoff and landing is fully autonomous. That means operator does not need to worry anything. Just push the button, it takes off, goes to the height. But the mission in between, it's adjustable based on what the logistics are. And the other thing is that our G25 could easily sustain 35 miles per hour wind, crosswind. And we have tested that in the field. So that's another, in terms of safety, that we are very keen and trying to advance it even further more in the next few months.